Hi everyone. Today we're going to learn about continue learning about hydrocarbons, about alkanes and alkenes. So where we left off, we were talking about the physical properties of hydrocarbons. Particularly here is alkanes. So one thing about physical properties of alkenes is that they have low melting point, boiling point. Now, because they have low melting point and boiling point, they mostly exist as gases or liquids. So now let's look what happens when the number of carbon atoms increase. The molecular mass of the hydrocarbon increases, and therefore density will increase. The melting point, boiling point will also increase. Now, why is this so? Because as the molecular mass increases, the molecular size increases. When your molecular size increases, the intermolecular forces of attraction also increase. So this means that more energy is required to overcome the forces of attraction. Okay, next, the viscosity increases. So what is meant by viscosity is about the flow of the liquid. So when number of carbon increases, again the molecular size increase, and when molecular size increase, the intermolecular force increase. Okay, when the intermolecular force increase, the tendency for the molecules to stick together is higher. Okay, next, the flammability decreases. So here please highlight, because this is the only one that decreases, the rest all increases. Okay, so why does flammability decreases? Because as you increase the number of carbon atoms, the amount of oxygen or number of moles of oxygen required to burn increases. So it gets more and more difficult because more oxygen is required. Okay, next, let's look at the structure of alkenes. So for this, before you can actually draw out the structural formula of the alkanes, you need to know 4 steps. So could you just find space on your notes? Okay. First step, draw your functional group. Second step, draw out the correct number of carbon atoms. Third step, you need to understand that each carbon atoms can only have 4 lines. The reason being is carbon, if you were to draw the carbon atom, I'm only going to draw the outermost shell. Each carbon atom only has 4 electrons. Therefore, it can only share 4 electrons, meaning that it can only form 4 bonds. So, here, number 3, you must draw 4 lines per carbon atom. Last but not least, you fill in the hydrogen atoms. Okay, so now let's look at what I mean by this. We will use ethane. So ethane is C2H4 because at means 2 carbon. So C2H2 times 2 plus 2 is C2H6. Okay, so ethane is C2H6. So first I draw out the functional group. So for alkane, this is the alkane group. There is no functional group for alkane. So because there's no functional group, we will skip the first step. Now, then we go on to the second step, which is the number of carbon atoms. So for this, you have 2 carbon atoms. 1, 2. Right? So we go on to the third step. 4 lines per carbon atom. So let's look at this carbon atom. You see that it already has 1 line here. So I'm going to use a different color. 1. Okay. Then I'm going to add 3 more to make it 4. 1, 2, 3, 4. Okay, so I'm going to number them here. 2, 3, 4. Then the next carbon atom, we do the same thing. 1, 2, 3, 4. After which, we will now fill in the hydrogen atoms per line. So just fill in the hydrogen atoms. and you're done. Okay, so what I want you to do is to try for propane and butane yourself. Once you have done so, you will check your work with Mr. Sip or myself. Next, we're going on to chemical properties of alkanes. So chemical properties essentially means the chemical reactions. So alkanes are generally unreactive except for when it's combusted, that means it's burned in oxygen, okay, or when it's substituted by halogens. If you recall, what are halogens? Halogens are group 7 elements. Okay, for example, your F2. Okay, the first reaction of alkenes is combustion. The combustion can occur for all hydrocarbons, and all hydrocarbons will burn completely in oxygen to form carbon dioxide and water vapor. So please highlight completely carbon dioxide and water vapor. One thing you need to know is how to construct the equation for the combustion of alkanes. So CH4, we're going to try with methane, CH4, this is gas, plus oxygen gas will give me carbon dioxide and water. So then we balance it. We balance it in the order of CHO. So we balance the carbon first. One carbon, one carbon. So this is balanced. Next we balance the hydrogen. There's 4 carbons on the left hand side, and there's 2 carbons on the left hand side. So we add 2 here. Then we have 4 hydrogen on both sides. Now lastly we balance the oxygen. So I have 2 oxygen on the left hand side, but I have 4 oxygen on the right hand side, so I need to add 2 here. So now this is balanced. So let's try for ethane. So for ethane, C2H6 is still gas, plus O2 gas will give me CO2 gas plus H2O. Okay, so again we balance in the order of C, H and O. 2 carbon, 2 carbon, 6 hydrogen, so this I have to put 3. So now on this side I have 4 plus 3, 7 oxygen. But on this side I have 2. So I can do this. But I cannot leave this as my answer. What I need to do is to multiply the whole thing by 2. So when I multiply the whole thing by 2, it becomes 2. 2 times 7 over 2 will give me 7. 2 times 2 will give me 4. 3 times 2 will give me 6. So this is the balanced equation. Next, why is combustion of alkanes important? Because the combustion of alkanes is exothermic, meaning it will give out heat or give out energy. Because it gives out energy, it is used as a fuel. So please highlight this point. Next, incomplete combustion of alkanes produces water, carbon monoxide, soot, and unburned hydrocarbons. The important thing you need to take note here is carbon monoxide and water. No matter what, water is always produced. Okay, and this is related to the topic in air. So you can go back to revise on air. Second reaction, we're talking about substitution by halogens. So as I said just now, halogens are group 7 elements. Fluorine, chlorine, bromine, iodine and astatine. Iodine and astatine is rarely used, so we're only going to focus on these 3 halogens. So what is a substitution reaction? This definition is important. It's a reaction where the hydrogen atom is replaced by another atom. In this case, an atom of halogen. the conditions is, okay, can you please cancel UV and spell out ultraviolet? Okay, Cambridge is particular about using the word ultraviolet. They do not allow short forms such as UV. So you must write down ultraviolet light. The reagents are your halogens and your alkanes. Okay. One thing to take note is reaction occurs step by step. So this means that halogens will replace the hydrogen one at a time until all the hydrogen has been replaced. Okay. So now let's look at ethane. So your ethane reacts with your chlorine. Okay, so what happens is one hydrogen atom is taken out and replaced by a chlorine atom. Okay, so chlorine comes in. Then what happened to that hydrogen atom? It then combines with the other chlorine to form HCl. Then it will continue on again. With other chlorine. So this chlorine will replace another hydrogen. So it can replace the hydrogen at any position. Okay. Alright. Okay. So can we replace on the other carbon? So that's it for substitution. So please answer the question here. So what are the possible products of substitution reaction of methane with chlorine? So please circle and we'll check your answer with Mr. C or myself. Next, we're going to look at alkenes. Alkenes is a homologous series of unsaturated hydrocarbons. So please highlight unsaturated. Okay. It has a general formula CnH2n. Okay, what does it mean by unsaturated? It means that other atoms can be added to the carbon atoms when the CC double bond opens up. So please highlight this. This is very important. So how do I know if something is unsaturated? Something is unsaturated when it has a CC double bond. This is the carbon-carbon double bond. For alkenes, they end with "ene". So for example, ethene, propene and butene. So please make the change, B-U-T-E-N-E. Okay. So try to complete the formula and molecular masses of the alkene homologous series. The minimum number of carbon atoms an alkene must have is 2. That's why the first member of your alkene is 2 carbon, is ethene. So write down here, this is your first member. This is the only one that in your syllabus where the first member starts off with a 2 carbon. So please answer the following questions on your own, and we'll go through with you when we see you next week. Okay. So, what are physical properties? Is exactly the same as alkanes. So, as the number of carbon increases, the molecular mass increase, density increase, melting point, boiling point also increase. Flammability decreases, viscosity increases. It's also important to take note that they also have low melting point and boiling point. Alright, so how do we draw the structure of alkenes? So we're going to look at propene first. It's already been drawn for you, so I'll go through with you step by step so that you can draw for ethene and butene and pentene. So recall the 4 steps that I shared earlier. First, draw the functional group. Second, you draw out the correct number of carbon atoms. Third, draw in the 4 bonds. Lastly, the 4th step, you fill in the hydrogen atom. So right now, we're going to draw out the functional group. So the functional group of alkenes, if you recall just now, it's C double bond C. So I'm going to put in C double bond C. So this is my functional group. Next, I add in the carbon atom. So please take note, when I add in the carbon atom, it's bonded by a single bond. Okay. So the only double bond is for the functional group. Next, I add in the 4 lines. So here I have 1, 2, 3, 4. So let's look at the second carbon. So right now I already have 1, 2, and 3. So I need to add only 1 more. Okay. So let's look at the last carbon. Okay, so again we have 1, 2. So I need to add 2 more. 3 and 4. Then I add in the hydrogen atom. Okay, so this is propene. So please do the same for ethene, butene, and pentene, and we'll check your work when we see you next week. Okay, so alkenes, how they manufactured? They're manufactured by the cracking of hydrocarbons. So cracking, please take note here, will produce both alkenes and hydrogen gas. Okay. And cracking is essential to match the demand for smaller fractions. So chemical properties, essentially all hydrocarbons will undergo combustion. So it produces the same products, which is carbon dioxide and water vapor. Please take note of the keyword completely. Okay. So for ethene, I've already done the equation for you. So please do the same for propene. Write down the balanced equation with state symbols. It's also good to take note here. Incomplete combustion of alkenes will also produce water and carbon monoxide, sometimes soot, and unburned hydrocarbons. Okay, we'll stop here for now. We'll go through addition reaction in the next lesson.